In today's lesson, we are going to look at partial factoring. So this is kind of part of our overarching kind of goals for this course, that by the end of the course, we should be able to convert between any form of the quadratic functions. Right? So we know we have the three forms, the vertex form, the factored form, and the standard form. And we've already looked previously about how to convert between them. Primarily, it's always been between the standard form and factored form, right? Whether we've been factoring or expanding. But now we're going to look at how to go from standard form to the vertex form, rather than having to go through and kind of turn it into the factored form and then go through finding the AOS and everything like that. Now it is going to have some of the kind of common steps. This is just going to allow us to do it a little bit easier, or a little bit more easily, and as well as when we run into the issue of what if we can't factor. So just as a review, we want to factor the following quadratic equations, determine the x-intercepts, the AOS, and the vertex. So this is, again, what we've done before. Please review the previous lessons if you haven't done so, or if you haven't done so, and if you kind of forget what's happening. So if I want to factor this, this is one of those simple trinomials. So I'm looking for two values that multiply to give me 63, and the same two values have to add to give me negative 16. We can, again, kind of can think about it, work through it. We should find that those two values are negative 7 and negative 9, because negative 7 plus negative 9 give me negative 16, and when I multiply them, I get 63. Now that I have those two values, I can just plug them into brackets with x, so x minus 7 and x minus 9. So here I've gone from my standard form to my factored form. So we've done this before. Now I can find the AOS. The AOS, remember, is the midpoints of the two x-intercepts. So actually probably what I should do first is find my x-intercepts. The nice thing about factored form, they come right from the equation. So in this case, it is positive 7 and positive 9, right? Opposite of what we see in the equation. The AOS are the two values added together and divided by 2. So 16 divided by 2 is 8. I can then find my max or min value, or the optimal value, by taking 8 and plugging it back into the equation. So I can find my max or min by taking the value of 8, so 8 squared minus 16 times 8 plus 63, or I could simply put it into the regular equation, so 8 minus 7 times 8 minus 9. That one probably works out a little bit easier to work with. Either way we look at it, we should get a value of negative 1. So now that I have my AOS and my max and min, or the optimal value, my vertex is 8 from the AOS and negative 1 from my max or min. Just kind of connect all these. And these two values came from here. So it's all kind of connected. These are the steps we can go through to find the vertex from the factored form. Now let's take a look at the next example. X squared plus 10x plus 7. So I'm looking for two values that multiply to 7. The same two values have to add to 10. If you think about it, we can't factor it the way that we know. We don't know what those values are, right? The only values that multiply to 7 are 7 and 1, and 7 plus 1 is not 10. So this one we can't do. So what happens when we can't factor our standard form equation. How do I find the vertex then? How would I go through those same steps? Well, let's look at some examples. So in class, you'd be working through this in a partner. We'll kind of just quickly simplify it or quickly jump to our answers. So if we were to look at each equation, I want you to go through, similar to what we did before. You can find the y-intercept easily because the y-intercept is just this last value here. But to find the x-intercepts, the axis of symmetry, the vertex, and then put it into vertex form, which again is y equals ax minus h squared plus k, we can follow the same steps that we had previously just done. Right? So the steps that we just did here, that can help us go through and fill out that table. So if you want a kind of a challenge for yourself or want to review, again, please pause the video, go through and try to find or fill out the rows for each of these equations. If not, again, you can kind of just wait a second and then we'll kind of just jump right to those answers. But again, I do recommend that you do try to do a couple of them just for practice and review. So coming back to our table, if you went through and tried it, this is what you should have found. Right? If not, that's okay because you can always just copy down this table or just look at this as we go through, because this is going to be kind of more seeing how we can kind of jump to our partial factoring. So we have our table filled out now. If we wanted to graph each of those equations, we would graphically see them as such. And what do we notice, or what do you notice? Is there anything that you notice about the equations and about the graphs? So let's go back up. Looking at all the equations on the left side, you can even look at the vertex form equations. Is there anything that you notice? Right, looking at the equations on the left, the equations on the right, is there anything that you notice about them? There should be one or two things that you notice. Something that kind of sticks out, maybe a pattern or something that stays the same or something that changes but in a kind of consistent way. Is there something that's the same? Or something that you notice? What about the graphical version? Is there something we notice here? So what we notice about the equations, we should notice in standard form, so the ones on the left, the first two terms were the same. They were all x squared minus 10x, and then they had something else after it. But those first two terms were all the same. In the vertex form, you might notice that the h value was the same. In the bracket, that h value was the same in all of them. Looking at the graphs, just going back up here, right, you might notice that they all seem to be along the same midline or that same axis of symmetry. Right, that AOS is the same for all of them. The axis of symmetry is not changing, it's the same. So what we can do, regardless of what that last value is, that C value, that y-intercept, regardless of what that value is, right, I don't even need to worry about it because I can use those values, or I can use the first two values to help me find the axis of symmetry. As you can see, even though we have a large C up here at the top, the first one, and if we look at the bottom, we have a C value of 0, I still get the same axis of symmetry. So if I'm not concerned about finding out what the x-intercepts are, and I'm only concerned about the vertex, I can just disregard that C value in general. So that's kind of where partial factoring comes into play. So partial factoring, we're going to disregard the C value and just factor the first two terms. Doing that will give us two values. Now we're going to call these kind of like imposter x-intercepts or fake x-intercepts, whatever you want to call them. We just want to be mindful that they're not the actual x-intercepts, but for our purposes, it may appear like that. So we can still use those two values to determine the x-intercepts, because we saw that it doesn't matter what that c value is, I can still find the same AOS. I'm going to find this axis of symmetry the same way. I'm going to use that to determine the max and the min, which will then help me find the vertex. So it's a little bit, it's kind of the exact same steps, except we're going to make it really simple and easy to help factor. So for example, let's go back to that original question or that original function that we couldn't factor at the beginning. Now what we can do is say, well, I'm just going to get rid of this c value. I know it's not really a factor in determining the axis of symmetry. So what I can do then is just worry about factoring the first two values. Now you could do it one of two ways. You could think of it as I can common factor and x out, and then get x and then x plus 10. Or what we can do, because it might be helpful, because what if we have an a value that might be a little bit different? What we can do is we can assume that that c value is gone or turned to a 0. So I'm looking for two values that multiply to give me 0 and two values that add to give me 10. In this case, because we're always disregarding that c value or removing it, you're always going to be multiplying to 0. So that means one of the values will always have to be 0, and the other value will have to be the value that we're looking for, that middle value. So in this case, x minus 0 and x plus 10. Those are the two values. Now, we want to take or find what our fake x-intercepts would be. So in this case, 0 and negative 10. So these are fake x-intercepts. We want to make sure we're mindful of that. We're not saying that these are x-intercepts, but we are going to use them to find our AOS. So what's the middle value? Well, the middle value, 0 plus negative 10 or minus 10 divided by 2 is negative 5. I'm going to take that value and plug it back into the equation. Now, I'm plugging it back into the original one. So y equals x squared plus 10x plus 7. So y equals negative 5 squared plus 10 times negative 5 plus 7. And then in the end, 25 minus 50 plus 7. So I end up with negative 18. So now I have my axis of symmetry. So for my vertex, my axis of symmetry is negative 5. My max or min is negative 18. I can plot that value of negative 5, negative 18. I can also plot my y-intercept, which from the original one is that c value, so that was a positive 7, which is our y-intercept. So I can plot that value. I can also mirror that. So if I'm at negative 5, then in the other direction, to 10, I'm going to have a negative 10, I'm going to have a value up there as well. So just kind of using that symmetry idea. And now I can sketch my graph. Right, I'm just looking for roughly how it looks. I can sketch it. It's not going to be accurate, but I can at least sketch it. And there I have my quadratic. Take a look at another value. So I do have a typo here, but let's just change this. No point in restarting. So this should actually be 30. So f at x equals x squared plus 10x plus 30. Now, regardless of what that last value is, I do know it's going to be my y-intercept, 30. But when I'm going through and I'm solving this, I'm going to disregard it anyways. I'm going to remove it entirely. So that means, again, I'm looking for two values that multiply to give me 0. Same two values add to give me 10. Very similar to the last one, 0 and 10. So again, it's the same kind of steps as the last one. So now I have x minus 0, x plus 10. So my two fake x-intercepts would be 0, negative 10. Again, remember, these are the fake x-intercepts. I'm only using them to find the axis of symmetry, which we know from the previous one. 0 minus 10 divided by 2 is negative 5. I take that and I plug it back into the original equation. So the original equation was x squared plus 10x plus 30. I now have negative 5 squared plus 10 times negative 5 plus 30. In this case, then, my y value equals 5. So therefore, my vertex is negative 5, 5. So again, I can plot my vertex now, so negative 5 and 5. If I wanted to, I can plot my y-intercept, which I know. I can then plot that same value using symmetry on the other side. And then roughly sketch or connect my points to form a parabola. The next one, we're going to go through and do the same steps, except we're going to now also write out in vertex form. So we're still going to go through the same steps. So I am going to identify that this is my y-intercept of 11. I'm just writing it off to the side because when I go through to find the vertex, I'm not even going to worry about factoring it. I'm going to cross it out completely. I'm looking for two values that multiply to give me 0, but add to give me negative 6. So this one is kind of a little bit different because we have a new value, but it doesn't really change it because in order to multiply to 0, I need 0. Or to add, so that 0 means I'm adding something, or one of the values is 0. And the only way I can get to negative 6 is if I have that same value. So it works out to 0 and whatever that b value is. Plug that into our equation. Right, we get x minus 0, x minus negative 6, or x minus 6. So when we go to our fake x-intercepts, and again, the only reason I'm putting this into brackets like this, not because I think they're x-intercepts, but because it helps me to remember that I need to take the opposite of that value for when I normally would be finding my x-intercepts. So the two values then are 0 and positive 6. Again, remember these are your fake x-intercepts. I can use them to find the AOS. 0 plus 6 divided by 3, or not 3, by 2, which gives us 3. I can take that value, plug it back into the equation, the original one, which is x squared minus 6x plus 11. 3 squared minus 6 times 3 plus 11, which works out to 2. And I now know my vertex is 3, 2. Now this is helpful because if I want it in my vertex form, y equals a x minus h squared plus k, I do need to know what my vertex is. So right now, I know x minus 3 squared plus 2. That's my h and my k, right from the vertex itself. What's the a value, though? What is the a value for this function? Well, if you remember going back and looking at all three formulas or types of quadratic formulas or functions, the a value stayed the same through all of them. So if I go back to my original standard form, the a value should be in front of the first value. In this case, I don't see an a value. In this case, my a value is 1. So again, the a value you can find in any equation. It should be the first number, the first term, or first coefficient. If we don't see anything, we can assume it's 1. So in this case then, the vertex form equation of this is y equals 1, x minus 3 squared plus 2. I can also sketch it because I know my vertex, 3, 2. I know the y-intercept, which is 11, and I can mirror that on the other side. I also know my step pattern. So I can go over 1, up 1, and put a point. I can go over 1, up 3, and put another point. Because again, my step pattern is based off that a value, which in this case is 1. And I can mirror that on the other side. So if you know your vertex and your step pattern, you can plot out multiple points. The nice thing is we also know a third point, that y-intercept, which we can plot and use symmetry to find on the opposite side. So one last example. This one's a little bit different because now we have an a value. We have an a value other than 1. It's not really going to change any of these steps, though. We do have one kind of separate thing to worry about. So I'm just going to keep in mind that this is my y-intercept, or -5. I am going to cross it out because I'm not going to worry about it. Now I need to go through and factor. Now this is the different thing here. When we do have an a value, we want to take that value out. So we want to take a factor out, or common factor, but we want to make sure that we're not common factoring the x out as well. Right? Essentially what we're looking at, by getting rid of that last value, essentially what we're looking at is something like this. So I'm not taking an x out because I don't have an x in that last term. In our last examples, we didn't really talk about that last term of 0, but essentially that's what we were doing. So when you have a value or an a value other than 1 and you're going through and using partial factoring, I'm just going to take that number out, that factor. So I'm not really fully common factoring. I am taking a common factor out, but I'm not taking the entire common factor out. So I'm going to take a 2 out, which leaves me with x squared plus 8x. And now I'm going to go through and find those fake x-intercepts. So two values that multiply to give me 0, but they add to give me 8. So 0 has to be one of them. Leaves me with the only option. Oh, it shouldn't be 8 because I didn't take my factor out. It should be 4. So I take a factor of 2 out, that leaves me with x squared plus 4x. So I'm looking for values that multiply to 0 but add to 4. So 0 is one of them, like we previously stated. 4 has to be the other value. Now I can kind of rewrite it out. So 2 and then 0, x minus 0, x plus 4. So my two fake x-intercepts will be 0 and -4. I can find the axis of symmetry by adding those two together. So 0 minus 4 divided by 2 is -2. And I can take that value, plug it back into the equation. So y equals 2x squared plus 8x minus 5. 2 times -2 squared plus 8 times -2 minus 5 should work out to -13. That means my vertex is -2, -13. my vertex form, ax minus h squared plus k. I know the h value from the vertex, so x minus -2 or x plus 2. And then the minus 13 is the k value. The a value, again, comes from the standard form, which in this case is 2. So now I have my vertex or my equation or my parabola in vertex form. I can sketch it by sketching the vertex first. I can plot the x or the y-intercepts if I want. Use that to kind of mirror it on the other side. I can use my step pattern if I need to. In this case, it's over 1 up 2, over 1 up 6. I can mirror that on the other side to get to other points and then roughly sketch. So there we have our quadratic written in standard form, and it's sketched. So again, the main thing from this is using partial factoring. We recognize that the C value doesn't really have any impact on what the axis of symmetry is. And so when we come across situations where we can't factor a standard form, we can partial factor. So we ignore that C value, we find our fake x-intercepts, we go through the same steps, finding the axis of symmetry, finding the vertex, and then plugging all those values in to roughly sketch it based off the vertex, the y-intercept, the step pattern, and we can use that to also help us come up with an equation in vertex form, in which we should be fairly comfortable with because we've seen the vertex form a lot, not just in the lessons, but also in the transformations. Right? So there's a lot of overlap in these formulas, so we should be fairly comfortable with them by now. If not, again, please go back and make sure you're reviewing the previous lessons. Again, this is more for going from standard form to vertex form. It makes it easier to kind of bypass some factoring issues that we may come across.